Okay, so starting with equations, we're going to look at just first what the difference between an expression and an equation is. The last unit we were looking at things like 3x plus 4, and that's an expression. To make it an equation, 3x plus 4 equals 0. The difference between an equation and an expression is just the equal sign. We can now solve for x. Okay, so when we're going through these types of questions, what we're looking at is first, we typically would solve by inspection. These are the types of things where it says like 6 plus a equals 11. And then you kind of think in your head and you're like, okay, well 6 plus what? All right, it's going to be 6 plus 5 equals 11. So a has to equal 5. Then the second question says 2 times something equals 14. Well, 2 times 7 is 14. So that means that b is equal to 7. Same thing here. Something divided by 5 is 4. Well, I know 4 times 5 is 20, and I need a negative, so I'm going to have h equals negative 20 divided by 5 is 4. That's perfect. Okay, so what we actually need to start thinking about, though, is actually solving using the opposite operations. So when we're talking about adding, the opposite of adding is subtracting. The opposite of subtracting is adding. So when we're looking at those, we're just going back and forth. The opposite of multiplying is dividing. And the opposite of squaring something, this is something that we don't see a lot, is square rooting. Okay, and it always goes the other way as well. So if we wanted to do the opposite of a square root, we would square something. If we wanted to do the opposite of dividing, we would multiply. Okay, so let's look at these questions. I'm going to write them out in 2 steps. You don't always have to, but if we had something like this, x plus 7, the way it would be move that to the other side and get that negative 2, so we'd have x equals negative 2 minus 7. Negative 2 minus 7 is 9. Okay, looking at the next question, we have to do the opposite of subtraction. So we have c equals negative 2 plus 5. So that means that c is equal to 3. Here we would have d equals 18 divided by 2. Well, d then equals 9. And then in the last one, f equals 2 times negative 3. That's going to be negative 6. So I'm going to go through all of them again slowly. The first one, we saw that this was a plus. The opposite of plus is subtraction, so I subtracted the 7 over on the other side. Here, in the second one, we saw it was a minus. The opposite of the subtraction there is plus. Okay, I'm going to just put arrows there. Here we're multiplying. Well, the opposite of multiplying is dividing. And then here we're dividing. So the opposite of dividing is multiplying. So I'm just doing the opposite operation each time. So let's look at these ones that are a little bit harder. Well, here we've got 5 times a. And we've got to get that 8 to the other side. Well, it's subtraction. So the opposite of subtraction there is addition. So we have to do 22 plus 8. Again, I'm doing this in a couple steps. You probably don't have to. Then we have 5a equals 30. Now we have 5a equals 30. Well, the opposite of multiplying is dividing. So we have a is 30 divided by 5. And a equals 6. Okay, I want you to notice the form that I'm using when I'm solving these questions. Okay, so here we have 5n. I'm adding 75 to 5n. Even though it says 75 plus 5n, they're both positive. So the opposite of addition, or the opposite of a positive, is a negative. So we need to subtract it over to the other side. So we have 225 minus 75. So then we're going to get 150. So we have 5n equals 150. Now the opposite of multiplying again is dividing. So we're going to divide 150 by 5. We're going to get n equals 30. Okay, so when we're looking at isolating variables, when we're solving for variables, which is isolating, what we need to do is the reverse of BEDMAS. Okay, so we need to do our order of operations in reverse. We need to do SAMDEB to solve for those. Okay, now here we did this answer. We found out our answer for this question we just finished. This is the question we just looked at here, was n equals 30. Now there's a way to formally check. This is the only way that I will accept a check. Okay, so a formal check, or a left side, right side check. Left side, right side check. Okay, so the way you do a formal check is you write left side equals, and then I'm going to look at the original equation, so the equation right at the top. I'm going to write 75 plus 5 times 30. Then I'm going to solve for it. 75 plus 150, 225. And then I'm going to write right side equals, and I'm going to write exactly what's on the right side. In this case, 225. Since the left side equals the right side, that upside down triangle that looks like a therefore statement, therefore n equals 30. Okay, that's the only acceptable way to do a check. All right, another question could be like, which of these is correct? Well, to find out which of these is correct, you could do it a bunch of different ways. You could do a formal check, you could solve, you could just substitute in and figure it out that way. So we're not doing it, we're doing it without solving the equation. So what I'm going to do is I'm just going to substitute these numbers in. Okay, so 7, it would be 2 times 7 plus 5. So that's 14 plus 5, which is equal to 19. So that one's no good. Then 8 is going to be 2 times 8 plus 5, which is 16 plus 5, which is 21. So that one is right, but we could just double check and make sure that our math wasn't wrong there and do this last one. So we've got that, and we get 23. So that one's wrong. Therefore, our answer is x equals 8. Okay. Last one. A high school football team has $1,000 raised to spend on team jackets. The cost of it is $50 per jacket. Which equation can be used to solve for the number of jackets? Okay, so, well, it costs $50 per jacket. So what that means is I need to have 50N somewhere in the question, because each jacket is going to be N, and 50 times that is going to tell me how much it costs. So that means the first one can't work. Well, if we look at the last one says that we've got 1,000N equals 50N. Well, right away, if I put a 1 in for both the n's, 1,000 doesn't equal 50. So then that one doesn't work. So what we're looking at here, because there was an n on both sides, this equation is kind of faulty. What we need to do here is we actually can solve this one. We can't solve this one. The only way the last one can be true is if n is equal to 0, because 0 times 1,000 and 0 times 50 is the same. So therefore, that's our right answer. Here's the questions for this note.